Good afternoon, all of you.
Good afternoon.
My name is Amrita Kulkarni and I am working as a training coordinator over here. Today we are going to start a session on HPLC, that is high performance liquid chromatography. But before going into that particular session, what we will see first the types of HPLC. Okay, so there are 4 types of HPLC techniques, that is normal phase, reverse phase, ion exchange and size exclusion chromatography. So we will see one by one the chromatographic types. Okay. So first is the normal phase HPLC. Okay. So what is normal phase HPLC? So this method separates analytes on the basis of polarity. Okay. So polarity is the main criteria in normal phase chromatography. So normal phase chromatography uses polar stationary phase and non-polar mobile phase. So whatever the stationary phase will be there, that will be your polar, and non-polar will be your mobile phase. So therefore the stationary phase is usually a silica, that is whatever the coating material is there on your particular column, that is a stationary phase, that is silica, and the typical mobile phase are non-polar, right? Hexane, methylene chloride, chloroform, diethyl ether and mixture of these. So these all are the non-polar solvents which we are going to involve in this particular chromatography. So what exactly will happen in this particular chromatographic technique is the polar sample, whatever the samples which we are going to carry out the analysis on this particular technique. So polar samples will be retained on the polar surface of the stationary phase, that is your column. Okay. And the non-polar, what it will do? Longer than the less polar materials. So whatever the polar materials will be get adhered or attracted towards your stationary phase to the longer time than the less polar molecules. So whatever the less polar solvents will be there, that will be elute first. Okay. Because your stationary phase is polar. So whatever the polar components will be there, that will be stuck on that particular stationary phase. So their retention time or their elution time, you can say, that will be longer than the non-polar solutes. Understood?
Yes.
So this is the normal phase chromatography. After that, the second one is the reverse phase HPLC. So what is reverse phase HPLC? So this is completely vice versa to normal phase HPLC. So what happens in reverse phase HPLC is the stationary phase is non-polar, unlike the normal phase chromatography. In normal phase, the stationary phase was polar. Here, in this case, the stationary phase is non-polar. The stationary phase is non-polar, that is hydrophobic in nature, while the mobile phase is polar liquid, such as the mixture of water, methanol or acetonitrate. Okay, so these all are the polar solvents. So in this case you are using water, methanol and acetonitrate. After that it works on the principle of hydrophobic interactions. Hence the more non-polar material is, the longer it will be retained. Exactly opposite condition to normal chromatography. Understood? So the normal phase and reverse phase chromatographies are based on what? Polarity of your sample. Understood? So these are the 2 types. After that, the third type of chromatography is ion exchange HPLC. What happens in ion exchange HPLC is the stationary phase has an ionically charged surface of opposite charge to the sample ions. That means what the stationary phase is made up of? Yes, ionically charged surface of opposite charge to the sample ions. That means whatever the sample component you are going to determine, that those sample components should have some charge, must have some charge. Okay, might have some charge. That charge will be opposite to the charge of the stationary phase, whatever the stationary phase components are there. Okay, so this technique is used almost exclusively with ionic or ionizable samples. So ion exchange chromatography is basically concerned with what? Ionic or ionizable samples. because it is based on the charges, right? After that, the stronger the charge on the sample, जितका जास्त strong charge आहे sample वर, the stronger it will be attracted to the ionic surface, and thus the longer it will take to dilute. The mobile phase is an aqueous buffer where both pH and ionic strength are used to control the elution time. So ion exchange chromatography is concerned with charges. Normal phase and reverse phase is concerned with polarity. After that, fourth type of chromatography is size exclusion, HPLC. So what is size exclusion? Earlier you told what was size exclusion. It is based on the size of the particles. Understood? So the column is filled with the material having precisely controlled pore sizes, and the particles are separated according to their molecular size. So whatever the separation will going to carry in this particular technique, it will be based on your size. That is why the name is size exclusion, HPLC. So larger molecules are rapidly washed through the column. The particles which are larger, those will get washed out, or not washed out, but it will elute fast from that particular column. Smaller molecules penetrate inside the pores of the packing particles and elute later. Understood? So whatever the smaller particles are there in your sample components, that will be get penetrate inside the column, and whatever the larger particles will get washed out through the column. So now you tell me, the size exclusion HPLC is based on what? Size of the particles, molecular size you can say. Understood? And what about this thing? Ion exchange is based on charges, correct? And these two, reverse phase and normal phase, are based on polarity. So I think you might have understood everything, like types of HPLC techniques. Understood? Now we see the applications of HPLC. Understood? So what are the applications of HPLC? The information that can be obtained by HPLC includes resolution, identification, and quantification of a compound. So these are some information which you are getting from HPLC. It also aids in chemical separation and purification. The other applications of HPLC include, what are the other applications of HPLC? Can anybody read?
Pharmaceutical applications, to control drug stability,
Yes.
tablet dissolution, study of pharmaceutical dosages form, pharmaceutical quality control.
So these are some applications which are involved, in which actually the technique is involved, HPLC. You can find the HPLC technique is widely used in pharmaceutical industries only, because there is a wide scope for the elution of any components or analysis. Analytical part is more based on HPLC in pharmaceutical industry. Okay. Next is, you can apply this HPLC in environmental applications also, in which field you can say detection of phenolic compounds in drinking water, biomonitoring of pollutants. So in environmental studies, you can apply HPLC technique for monitoring of pollutants and phenolic compounds if you want to detect from drinking water. Then what other functions or what other applications are there? Forensics. Forensics for quantification of drugs in biological samples, identification of steroids in blood, urine, etc. Then forensic analysis of textile dyes, and determination of cocaine and other drugs of abuse in blood and urine, etc. So these are the applications which are basically involved in forensic science, or you can say in pathological lab also you can use HPLC. You might have heard the sugar analysis, whatever the blood sugar which you are determining for diabetic patients. Okay, that analysis is carried out on HPLC. Okay, so these are some applications of HPLC. Then what other scopes are there for its applications? Food and flavor. measurement of quality of soft drinks and water, sugar analysis in fruit juices, analysis of polycyclic compounds in vegetables, and preservative analysis. Whatever the preservatives are added in your food sample, those you can determine with the help of HPLC. Okay. Then what are the other applications in clinical tests? Urine analysis, antibiotics analysis in blood, analysis of bilirubin, biliverdin in hepatitic disorders, then detection of endogenous neuropeptides in extracellular fluid of brain. So these are some applications in clinical tests or pathological test, you can say. So there are some advantages of HPLC. Separations is fast and efficient, that is high resolution power. Continuous monitoring of the column effluent. It can be applied to the separation and analysis of very complex mixtures. Then accurate quantitative measurements, repetitive and reproducible analysis using the same column. That means you can analyze any analysis. It is repetitive and reproducible analysis on the same column. That means on a single column you can get a repetitive and reproducible analysis.
How much time it takes to complete one sample?
What?
How much time it takes to complete one sample?
So what is the next advantage? It can be applied to the separation and analysis of very complex mixtures. That means you can analyze very complex substances or mixtures also on HPLC. Accurate and quantitative measurements you will get on HPLC. Then adsorption, partition, ion exchange and exclusion, column separations are excellently made. These are advantages of HPLC. So along with the advantages, there are some limitations of HPLC. So what are those limitations? Despite its advantages, cost. HPLC can be costly, requiring large quantities of expensive organics. Organics means what? Whatever the mobile phase or the solvents you are going to use, those are quite expensive. So the cost is the basic limitation on HPLC, and HPLC instrument itself is a costly instrument. Then complexity. HPLC does have low sensitivity for certain compounds and some cannot be detected as they are irreversibly adsorbed. It is having low sensitivity for certain compounds, but some cannot be detected. Some compounds cannot be detected on HPLC because they are irreversibly adsorbed, or they will get adsorbed on particular stationary phase. That too also irreversibly adsorbed. Then volatile substances are better separated by gas chromatography. That means whatever the volatile components are there, that you can determine on GC, but not on HPLC. So this is the limitation of HPLC. So this was for limitations, and everything was for about types of HPLC, advantages and limitations. Understood? I hope you understood everything, whatever I took. So that's all for this HPLC session.